We're back. We had some technical difficulties in that last little go around, but it's all good. So we're doing our proof. That's how we're explaining. We're using a proof to explain why these triangles are similar and writing a similarity statement. So we said angle A and D are right angles. That was given in the picture, right? That was what was given in the picture. What do we know about right angles? I mean, they're 90 degrees, and they're definitely all congruent to each other. So angle A is congruent to angle D because all right angles are congruent. That's just, I mean, that's what it is. They're all 90 degrees, so they have to be congruent to each other. They're all the same measure. Up here we talked about the angle similarity postulate. So I think I'm going to try to use that to prove that these are similar triangles. So to use that, I need to know that two pairs of angles are congruent. I've got the ones congruent because they're right angles. I need another pair of angles. Who else is congruent? Who? Tell me. Oh yeah, these vertical angles. It came out funny. Vertical angles. Those are congruent. Angle BCA. Angle BCA is congruent to its vertical angle ECD. The vertical angles are congruent. Sweet dog. Now we got two pairs of angles that are congruent, so we can say these triangles are congruent by the angle similarity postulate. Which two triangles? How about BAC? So I went from something that had no markings to a right angle to that one angle mark. Triangle BAC is similar to, so that means, again, we went from no marking to right angle marking to this one arc. So we're going to do no to right to 1, so E to D to C. Triangle E to D to C by the angle similarity postulate. Do you need to write similarity postulate? No, you can just write angle. Awesome. So awesome. All right, let's keep on cruising. Oh man, now it's your turn. Are the following triangles similar? Check out those angles. Use what you know about the sum of all the angles in a triangle. And let's work it out. You gonna work it out? All right, example number 3. Why are the triangles similar? And write a similarity statement. Hint. Find angle U first. Angle U? Who's angle U? Oh, you mean this angle here, which should technically be called VUP, angle VUP, because U could be part of QUV, so we really want that guy. Okay, cool. What do I know about this angle? I know that guy is 140 degrees, so I know that guy. Oh, wow, that guy's 40 degrees. Cool. What else do I know about these two triangles? I got this little triangle and this big triangle. Oh, they share an angle. They share angle P. The little triangle's got angle P in it, and the big triangle has angle P in it. So they have an angle that's shared, which means it's the same. And then we have two corresponding angles that are congruent. So we know they're similar by angle, right? So we have angle RQP is congruent to angle VUP. We also know that angle P is congruent to angle P. Something is always congruent to itself. That was our reflexive property, right? So we know that triangle QRP is similar to triangle UVP by angle. Right? By angle. That was reflexive property. Great. Let's write our similarity statement. So side QR corresponds to side UV, which is equal to RP over VP, which is equal to QP over UP. Great. Now let's fill in some things we know. RP is 15. RQ, which is the same as QR, is 10. UV is 7. Find the other things. So QR, same as RQ, 10 over 7 equals, RP is 15 over VP, which equals QP over UP. I don't think I need to know that, do I? I don't think we do. We could solve for VP. And then if we knew what VP was, we could subtract it from RP to get RV. Great. So let's do that. Solve for VP first. 10 times VP, we're using our, what's that? Cross product property, so true. 10 VP equals 7 times 15. 7 times 10 is 70 plus 7 times 5 is 35. 70 and 35 is 105. 105. Divide these suckers by 10. That should say P. So VP equals 10.5. So this whole thing, R to P was 15, V to P is 10.5. So that R to V must be the subtraction action between those two. 15 minus 10.5. R to V equals 4.5. Man, we're just like so smart. Like a bunch of geniuses up in here. Yeah. Alright, so we used the angle-angle similarity to show that triangles were similar. We've also got 2 more ways we can do that. Side, side, side similarity and side, angle, side similarity. So, side, side, side says if the corresponding sides, all the corresponding sides of 2 triangles are proportional, then the triangles are similar. So let's say, let's call AB 14, let's call BC 18, let's call AC 10, let's call QP 7, QR 9, and PR 5. So if all 3 pairs of corresponding sides are proportional, then triangles are similar to each other. How would we do that? We check the proportions. So side PQ corresponds to side AB, right? So PQ over AB should be equal to QR over BC, should be equal to PR over AC. Well, let's see if that's true. PQ was 7, AB was 14. Is this true? That that's equal to QR, which is 9, over BC, which is 18. Is it true that that is equal to PR, which is 5, over AC, which is 10? Are those all equal to each other? Yeah, dude, they're all half. 7 over 14, that's a half. 9 over 18, that's a half. 5 over 10, that's a half. Half and half, 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 half. So the side similarity, if you want to talk about that abbreviated style, you need to put side similarity to make a distinction between side congruence, which we used back in the day. Side angle side is really similar to side angle side congruence, but instead of having the sides be congruent to each other, they're going to be proportional. So side similarity says if we have a pair of angles that are congruent and the sides that make up those angles are proportional, then those triangles are similar. If one pair of angles is congruent and the sides that form the angle are proportional, then the triangles are similar. We've got a pair of angles that are congruent. If we would need to show that AB over QP is equal to AC over PR. So if you know these sides are proportional and the angle between them are congruent, then boom shakalaka, you can use the side angle side similarity theorem to say that those triangles are similar. Hot diggity, dog diggity, boom, what you do to me. All right, move on to the back side of the paper. Example number 1, use a paragraph proof to prove that triangle ABE and triangle ACD are similar. All right, we're given that AB is 6. We're given that AC is 18. We're given that AE is 4. That's a funny looking 6. We're given that AD is 12. Why are these two triangles similar? Almost said congruent, but I meant to say similar. What are our choices for proving things are similar? We could do angle, side, similarity, or side, angle, side, similarity. Well, we're given two sides. Right? I have AB and AE of the tiny triangle, and we have AC and AD of the big triangle. So we're probably not going to use angle. We're also not going to use side. I don't know anything about the third side. I don't know that these are right triangles. So I can't solve for the third side. So my only option is side angle side similarity, but that means I need to know an angle. Which angles are congruent between this little triangle and this big triangle? Oh, how about the angle that they share? Yeah, they both have that little angle, that angle A. Triangle BAE has that, and triangle CAD has angle A. So, let's say, since angle A is a part of both triangles, yes, you can use symbols in your paragraph. Angle A is congruent to angle A by the reflexive property. To use this Side angle, side. We need to show that the sides are proportional. Let's just say we see that, I mean, because I'm assuming it's going to be true because it says prove it. So let's see that AB, which corresponds to side AC in the big triangle, is equal to AE over AD in the big triangle. So I'm going to say we see that that's true. Let's show that's true by, what is AB? It's 6. That's 18. AE is 4 over 12. We should reduce each of these. Divide by 6, divide by 6, divide by 4, divide by 4, and we get 1/3 equals 1/3. So yes, you can show some equations in your paragraph proof. So triangle ABE is similar to triangle ACD by side angle side similarity. Great. Great. Cool. Miss Akin, are we going to have to do like a million proofs like we did back in first semester? No, not a million proofs, but some proofs. Not none proofs. Some proofs. They're good for your brains, honey. They're real good for your brains. All right, on your own, which triangles are similar? Explain why they're similar. Remember, you got 3 choices. Are they similar by angle, angle, side angle, side similarity, side angle, side, side, side similarity? Those are your 3 choices. That, my dears, is for you on your own. What you're going to do on your own. All right. We're going to do 5 together, and you're going to do 6 also on your own. Lift those weights, Sonny Jim. All right, question 5. To measure the distance AB across a lake, a surveyor standing at point S locates point A and B and C and D as shown. The surveyor finds that B to C is 60 meters. C to S is 4 to 8 meters. C to D is 40 meters. And D to S is 52 meters. And A to D is 65 meters. So it looks like he measured everything except for A to B. Why did he do that? Why did he not measure the only thing he wanted to measure? I'm gonna guess because this is like a long way, and maybe he doesn't want to swim the whole way and figure out how long he swam or something. I don't know. That's what that is. Well, these must be similar triangles. That's the only way we could be doing that here. If he's standing here and measured some stuff, right, that angle between the tiny triangle and the big triangle are the same. Let's just double check that these are similar triangles. So let's look at CS over BS, haha, and let's see if that is equal to DS over AS. CS is 48. BS is 16. Check and see if this is true. Oh, no. BS is not 60. BS is 60 plus 48. That's 108. 108 over 52 over A to S is 65 plus 52. 65 plus 52 is 7 and 1/17. Huh. Well, let's see what we get. Let's do some division. We could reduce these fractions. I'm not into it right now, so instead what I'm going to do is just some straight up division. What is 48 divided by 108? Well, that is 0.4 repeating, which is actually 4/9. And let's see what happens when we do 52 divided by 117. All right, okay, got it. They're both 4/9 or 0.4 repeating, which means we have similar triangles, which means we can use a ratio to figure out this other dude. Okay. So the ratio 48/108 will be the same as the ratio of 40 to the side that we're looking at, because we could write a proportionality statement for all the sides, right, which we did for 2 of these to make sure they were similar. Let's just use this. 48/108 will be equal to 40 over the side we're looking for, AB. When we did our division, we got 0.4 repeating, which I said was 4/9. So we can go ahead and say that's 4/9. We must have divided both of these by 12 to make that happen. That's 48 divided by 12 is 4. 108 divided by 12 must be 9. 40 over AB. I'm not going to give you the punchline. You can do that cross multiplication. Give yourself some more practice. Lift some of those mental weights. So you're going to find what AB equals after you do your cross multiplying. All right. Scholars, you've done an amazing job. You've done such a good job. I'm so proud of you. Keep on keeping on. I love you. I will see you next time.